it was an actual creature, a living creature in my eye.
The Acanthamoeba is a free-living amoeba that is capable of causing human disease. The Acanthamoeba is the most common amoeba found in nature. It can be found in all types of water, soil, and water-air interfaces. The Acanthamoeba has been isolated from bottled water, sewage, compost, surgical tools, hospitals, eye wash stations, shower heads, pigeon droppings, vegetables, cooling towers of nuclear power plants. The Acanthamoeba is found almost everywhere. The Acanthamoeba has two stages in its life cycle. The first is an active trophozoite stage, where the Acanthamoeba feeds on organic particles as well as other microbes. When in this feeding trophozoite stage, it can divide mitotically under optimal conditions. The second stage is a dormant double-wall cyst that has been known to survive in vitro for more than 20 years and is very resistant to disinfection. The Acanthamoeba does not require a vector for transmission to human or animals. Modes of transmission include inhalation of cysts carried by the wind through the respiratory tract or direct skin contact with soil or water. Two common diseases caused by the Acanthamoeba are GAE and Acanthamoeba keratitis. GAE infects the central nervous system of immunocompromised individuals and almost always results in death. But because of the Acanthamoeba's mass presence in the environment, most healthy individuals have developed anti-Acanthamoeba antibodies that protect them from GAE, making infections rare on immunocompetent individuals. Acanthamoeba keratitis, on the other hand, most commonly infects the eyes of immunocompetent individuals and causes severe pain and even blindness. Acanthamoeba keratitis can infect anyone, but is most commonly found in those who wear contact lenses. The incidence of disease in developed countries is low, with approximately 1 to 33 cases per million contact lens wearers. Acanthamoeba keratitis, if treated correctly, has a favorable prognosis for recovery. There is not one single drug that is effective for therapy of Acanthamoeba keratitis, but most therapies, at least in the initial stages, are intense with hourly applications carried out for 3 to 4 months. And even with the intense treatment, there is a common reoccurrence of infection due to the resistant double cyst wall stage. The eye is a privileged site, and because of that, the Acanthamoeba is protected from immune responses that an Acanthamoeba might elicit from another area in the body, thus making the body unable to develop immunity against Acanthamoeba keratitis. Treatment and control options to prevent transmission via drinking water and wastewater is still not completely understood. The Acanthamoeba in the cyst stage is very resistant to inactivation by water disinfectants such as chlorine, bromine, and UV. Doses used in drinking water treatment methods would not be expected to eliminate the Acanthamoeba. The good news is the cysts in some Acanthamoebas are large enough to be removed by filtration. The main control strategy is to make people aware of the risks associated with contacts. The Center for Disease Control and Prevention has identified certain practices that can increase the risk of getting Acanthamoeba keratitis. These are storing and handling lenses improperly, swimming, using hot tubs or showering while wearing contacts, coming in contact with contaminated water, and having a history of trauma to the cornea. There is no perfect detection or diagnostic method to date for the Acanthamoeba in the environment. Pairing of different assays is required to achieve the best results. The common environmental detection methods include microscopy, PCR with genus-specific primers, qPCR, and fluorescence staining. Each method has its own strengths and weaknesses. But wait, remember this part, where the Acanthamoeba feeds on other microbes and nutrients in the water? Some of the microbes it feeds on are able to grow and reproduce within the cytoplasm. The reason this is alarming is that the dormant double cyst wall stage of the Acanthamoeba protects pathogenic microbes, such as Legionella, from treatment. The Acanthamoeba has been called the Trojan horse of the microbial world, and because of this, there is raised concern that the Acanthamoeba could be used as a bioterrorist weapon. There is growing interest in understanding how the Acanthamoeba acts as a reservoir for other pathogenic microbes, and how we can target them in treating drinking water and wastewater.